Okay, this week we're going to work on t-tests. I'll briefly introduce what a t-test is in a little bit later, but as part of sort of building towards that, we'll talk about the data that we're using. So first, I should share my screen. And so what we're going to use is this data called smoke ban in the package AER. And I'll read that in quickly, and we can take a look at the top few lines with head. What this data has is it's 10,000 individual observations looking at whether workplace bans on smoking make people less likely to smoke. And so it has information on whether the people are smokers, whether they work somewhere with a work ban, their age, education level, race, gender. So just a few characteristics that we can look at. And the core sort of idea is, do workplace bans reduce smoking? And so we're going to use a t-test to see whether the difference in the percentage of people that smoke in places with a workplace ban is different than the percentage of people that smoke in places without a workplace ban. And so we're going to look at those two variables first with the table. The top line is for people who smoke, so 7,500, 75, 77 do not smoke in the data. 2,423 do smoke. So about 75% don't smoke, 25% do smoke in total. 3,900 work in some place without a smoking ban, and 6,000 work someplace with a smoking ban. And so what we want to see is whether there's a significant difference, whether that ban makes a significant difference between these two groups and the rates in which they smoke. Because we know that this is just one sample, it's a collection of 10,000 people. And we can know very quickly what percentage of people smoke within the sample. What we want to know is whether people outside of the sample, people that we haven't actually measured, whether there's a difference there. Because we want to be able to infer things from our sample to the population. So the population here is sort of all workers. And so within the population, who we aren't able to collect data on everyone, we want to know whether workplace bans on smoking has an impact for them. And so one way to test that, one way to look at it, is by using a t-test. So the setup of a t-test is fairly straightforward. The command is t.test, and then you enter the two variables of interest, in this case, smoker and ban. This is going to give me an error though, which I do sort of intentionally in order to give you some hints about how to get around it. So when I run that, it tells me that it gives me this odd error calling var x on a factor, x is defunct. What that's telling me in sort of decoded language is that one of the two variables is not in a format that it wants. And so we have the two variables here. The left side of this equation, smoker, is the dependent variable, which is going to depend on what we have in the independent variable on the right side of the equation. And what this is trying to tell us, in as confusing of language as possible, is that the dependent variable is in a form it doesn't like, that it's a factor, and it can't use a factor. And so I can sort of show that here by adding something. I can check what form a variable is by writing is factor, and this will come up true because smoker is a factor. And it's a factor which is sort of saying that it's words. It's different levels of words. And we know that from earlier, that it's coded as no's and yeses. And so what the t-test wants is something numeric. It wants the outcome to be numeric. And so we need to change it, and there's a few different ways we could change it to actually use it in the t-test. One way is just by wrapping it in as numeric. So let me take this out for a second. If we wrap it in as numeric, we could turn it into as factor, but we want to turn it into as numeric. And what we have, instead of yeses and nos, which is above, we now have ones and twos. And so the t-test can use ones and twos as two levels as the outcome representing whether people are smokers or not. Okay, so now that we have it in this form, we can run the t-test. And a t-test gives us a lot of output, a lot of different things, all of which is telling us something important and interesting, but we can work from sort of the most important parts and work through everything else as we go. The first thing you want to look for in a t-test is the p-value, because the p-value is telling you the probability that the two groups are not different. The p-value is telling you the probability that the two groups are not different. And here it's being written in scientific notation, which can make it a little bit confusing. This is 0.2 with 16 zeros in front of it. And if the value is less than 0.05, we generally regard it as statistically significant. A 2 with 16 zeros, I can write that sort of out. P is less than, this is less than 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is what our p-value is, which is much less than 0.05. And so we would say that, yes, there is a statistically significant difference in this data. And so we are confident that in the population, there is also a statistically significant difference made by workplace smoking bans and how many people smoke.
So just to rephrase that point, just to make sure, what you mean is that the probability that you'd get this kind of sample, even though there actually wasn't a difference between the two groups, the probability of that happening is 0.00000000000 blah 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 22.
Right.
And generally, we're looking for something where you would say there's less than a 5% chance that these things are actually the same. And since this is like way less than 5%, you can conclude that they're different.
Yeah, that's a really great way of restating it. The sort of core idea is, are the two means equal? Are the two means equal, which in this case is the percentage of people that smoke where there is a ban and people that smoke where there isn't a ban? Is the difference in those means equal to 0, or indistinguishable from 0? And what we're saying is that there's a very low chance that there is no difference. We know what the difference is in our sample, and that's shown down here. So this is a little odd because it's 1.28, but that's because of how we sort of created the variable. But 29% of people smoke in the no group where there is no workplace ban, and 21% smoke in the group where there is a workplace ban. And so we know that that's correct for the sample, that it's 29% and 21%. What we really want to know, though, is whether that difference would be consistent if we got 10,000 other people or any other sample, whether there would still be some difference, and whether the workplace ban would still lower the amount of smoking. And based on a couple of things go into this test, which R is doing behind the scenes in sort of the mechanics. It's looking at how big the difference is between the two means, how large our sample is, and how much variation there is in our two means. And so the larger our difference is, the less variation there is in what we're measuring, and the larger our sample is, the more likely we are to get a significant result. We don't want to get a significant result if the difference isn't really true. But that is those are sort of the levers and what determines whether our result is significant or not. So wrapping the variable in as numeric is one way to make it into something we could use in the t-test. Another way is by creating a new variable. And
Wait,
so,
actually, let me just see if I can say something back to you, because I suspect that it's not immediately going to be clear to some people.
yeah.
The way that you are forming the inference that there's a sort of 29% 29% smoke in the first group where there is no smoking ban, and 21% in the group where there is a smoking ban, is that when we created the numerical variables, we made the no's all be 1, right?
Mm-hmm.
For if you don't smoke, then you get counted as a 1, and if you do smoke, you get counted as a 2. And so the sort of the the number that we see 1.289595 or 1.212037 is just going to be the proportion in that sample who got marked down as a 2 instead of as a 1. And so basically you can infer those percentages by just subtracting out that 1 and just looking at the decimal point after that, to see what the percentage is. Is that right?
Yeah, and so using the wrapper as numeric is a little bit coarse unless you understand the data, because then you're giving up control of what the levels are.
Mm-hmm.
It wouldn't be sort of automatically intuitive to me that this would be coded as 1, 2. And you also don't get to choose who's a 1 or who's a 2. And so sort of a more complicated way to do this is by making a new variable, which is what I do down here, by creating a new smoker numeric version with an if else. And so I say, if the person is yes a smoker, make them into a 1, or the other, if not yes, make them into a 0. And I can add a table here, and we can take a look. And I think this is an easier way of doing it, because now smokers are coded as 1s, which makes sort of the comparison a little bit easier. And we can rerun the t-test with this. And you can see that we get essentially sort of the same percentages, right? It's sort of making them 2s or 1s or 0s or 1s is sort of an automatic translation, but it makes it a little more confusing when the mean of one group is 1.29 and the other one's 1.21. So this comes out a little bit cleaner. It's a little more easy to automatically understand what they are. But it's sort of, you can see the sort of direct translation between those two, and everything else comes out exactly the same, which is nice.
Are we going to talk about what happens if you have like multiple levels rather than just 2?
So that's one really important part of t-tests. T-tests can only be conducted if your independent variable has 2 levels. So workplace ban, yes, no.
I mean your dependent variable.
Your independent variable. So the workplace ban is the independent variable here.
Right.
Whether someone is a smoker is the dependent variable.
Right. So you needed to turn the dependent variable into like 1s and 0s to run the t-test.
Yeah.
But what if there are like 3 possible, like what if it's like you have people who are heavy smokers, light smokers, and non-smokers, and you want to run some kind of like inference about that?
Yeah, so for the dependent variable, you can have multiple levels. If I wanted to look at the impact of smoking on income,
Yeah.
I could do that. The independent variable can only have 2 levels because we're looking at the difference in means between those 2 groups. And so if I wanted to, one of the variables in this data is age. I think education has multiple levels too. If I wanted to see whether young people are more likely to smoke or not, age, I can do this. People who don't smoke on average are 29 years old, 39 years old. People who do smoke are 38 years old. So it's a small difference, but it is statistically significant. if I wanted to switch those two variables and make age the independent and smoking the dependent, I would get this error that what it says is the grouping factor must have exactly 2 levels, which is saying the group that I'm testing, age, has more than 2 levels.
Right. Okay.
And so that's one limitation of t-tests. T-tests are a really nice and simple tool for testing for differences, but you can only do it when you're looking at 2 groups, which is limiting. Tools we'll talk about in future weeks will have sort of more flexibility, and more power brings sort of more opportunities to do things wrong, I suppose. So those are the core things about the output. Just sort of getting started. Those are the things to look at: the 2 means for the groups, the p-value. Everything else is interesting, but it's stuff you'll pick up later. Before I turn it over to you, we can quickly look at what Pander does to this, because it makes it a little bit more attractive. And so it just puts it all in sort of lines, but it isn't that different. So all of that. So now I turn it over to you to practice. I give you this challenge at the end of the worksheet. Before we do that, I guess, any other questions?
I think so.
Okay, then I will stop my share and let one of you take over.
You have disabled screen sharing.
I
For
always
the program,
do.
Van Holm.
Somebody screen shared during class last night. Who can share? Why does this always go? Okay, try now.
Yeah. Jake, you want to do this or you want me to do it?
Yeah, I got it. Well, I don't know if I don't know. We'll
I
see.
like the confidence.
I'm sharing my screen anyway. Okay, so let's see. So we want to see whether men or women are more likely to smoke. You started above with this table, and I'm feeling the urge to start there, though I don't know if that actually makes sense. So, all right, so we want to see, oops. Oh wait, hold on, gotta insert my code chunk. Right, so you had table, and then smoke and then let's see.
Your B is lowercase.
Capitalized?
Oops. Sorry, what's that, Donnie?
Well, I was just that.
All right. I don't know if this is the thing to do. What is this gonna tell me?
Well, so it's a
Okay.
good thing to check because it shows you that your gender variable only has 2 levels. So you know you can use it in a t-test.
Okay. Right, but I have to make this numeric. So
And
let's
is
see.
it numeric already? Oh, well, but we want to make smoker numeric, not gender.
Right. Right. So what did we do for that above? We did
You could do as numeric.
is numeric. As numeric?
You could also do the
As numeric.
yeah, there's that as numeric, and then there's the if else thing. Seems like
Right.
we don't do either.
Okay, so we want as numeric. Oops, there it is. And then we want smoke. Well, we're working within smoke ban, right?
Mm-hmm.
Is this right? Smoker. Does that look good so far?
The S shouldn't be capitalized on smoker.
Smoker. That doesn't look useful.
I think it's fine, but we just need to put that into the t-test.
Okay, right.
So Eric had displayed it to us as a table before, but I don't think that's strictly necessary to accomplish what he has asked us to accomplish.
All right. So we want it in the t-test,
Mhm.
and we want to know about whether men or women are more likely. So then we have one variable is whether it's a smoker, and then the other is gender, right?
Mhm.
Mm-hmm.
So then we use the tilde.
I think it's outside of the, oh, well, you can do it that way too.
Yeah, you're right, Don. So you want the tilde outside of the as numeric,
Okay.
because
So,
the as numeric is going to apply to everything you put in that set of parentheses.
right. Okay. So is that what I want?
That looks good.
Let it ride, baby. Yeah.
Okay.
Do you want to take a shot at interpreting this for me?
Let's see. So what is it, like 25.7% of those in the male group are smokers, 23 in the female group are smokers.
Mm-hmm.
And we have statistical significance.
Yeah,
All right. That's it.
that's exactly right.
All right.
Okay.
That was exciting.
All right. Well, that's it for t-tests.
Nailed it.